Hi, everyone. Welcome to Earth Science. I want to say a few things today about the abbreviated 6-week schedule. I'll be only highlighting really some of the main topics like the rock cycle or plate tectonics. We'll look a little bit at earthquakes and then geologic time scale, and then we'll kind of wrap everything up. So um, just so you know, we will, kind of move through some of the things that we would normally cover, and I'll have to eliminate some of the other things. Unfortunately, the hands-on fossil and mineral labs will be trying to do some of those things in online simulations. So we'll take a look at those too. So when we're talking about earth science, we're obviously talking about any science, right? Any part of science that relates to the earth itself. And in addition to the physical earth, we'll be looking at our galaxy. So all of those neighbors, for lack of a better term, that we see in space. Normally, this is something we would cover, but we're probably going to eliminate the space piece. So when we're talking about earth science, remember, it includes a lot of different sciences. Mainly what we're going to focus on is the geology piece. Geo, of course, means earth, and the suffix OGY always means the study of. So with geology, we'll look specifically at the study of Earth. We'll add a little bit of oceanography, because we're going to look at the water cycle and how that affects the Earth. Meteorology, we will study a little bit of. We'll look at atmosphere and how global climate change affects that. Astronomy, the study of the universe, of course, we will have to do without, because of the brief 6-week schedule that we have. Some of the other things, if we have some time, I'll look at some of the natural hazards of the earth and energy resources and things like that. So, to begin this course, we have some facts that we have to agree on. One of those is that the Earth is about 4.5 billion years old. So when we're talking about recent Earth history, we're talking about really within the last billion years or so, which really isn't recent as we would think of recent. So when we're looking at the geologic timescale, what I'll do is kind of break this down into the different units that we use with Earth, epochs and eras and so on. If you try and think of, the entire Earth being in a 1-year cycle, so 4.6 billion being kind of broken down into a 1-year cycle, we would see that, humans really would not show themselves on Earth here until almost the less than the last minute, right, of the last cycle of that particular year. So we're looking at, December 31st, which would be the last day of the year, at almost midnight, that the new millennium would be starting. So recent is a relative term. Now, the other thing we have to agree on is, what the natural world encompasses, right? We know that science assumes a couple things about the natural world, right? It has to be consistent and it has to be predictable. And our goal, of course, is to look at those patterns and then be able to make predictions. And that's no different with any of the things that we'll study in earth science. A third thing that we will agree on or have to agree on is that there are various hypotheses out there as to the formation of the Earth. The one that we will look at in this course is what is called the nebular hypothesis or theory. And it looks at the Earth being composed mainly of hydrogen and helium, two gases, right, that can't, sustain life. And for the first, several billion years at least, there was no life here on Earth because it was couldn't be sustained because of those gases. And as we see now, almost 5 billion years later, we see that we have a Earth whose atmosphere is roughly about 79% nitrogen and about 19% oxygen. And then the remaining 1% is various trace elements like neon and krypton and elements like that. So those are kind of the things that we would have to agree on. That initially we had all of these gases, formed kind of what's called kind of a protoplanet, which is the precursor of Earth. And then from there, the galaxy was developed. Now we will look, very much at the layering structure of Earth. So we're going to look at, how the crust of the Earth is put together, the mantle, what magma, all those pieces that tend to lead into what we call the rock cycle, because that's an important cycle that we'll definitely take a look at. Some of the spheres of the Earth that we'll take a look at, I mentioned we'll definitely take a look at the hydrosphere or the water cycle, because obviously almost 3/4 of the Earth is covered in water, and most of that water is not usable as fresh drinking water. So we'll take a look at how we manage to take that, less than 1% of the Earth water that's available to humans and other animals and plants for drinking water, and how we manage to make that be enough for over 7 billion people. So take a look at that. The atmosphere is another sphere that we'll look at. And again, we'll look at that insofar as we'll take a look at current topics like global climate change, and we'll look at some of the carbon dioxide and some of the greenhouse gases that affect our atmosphere today. When we're talking about atmosphere, remember we're talking about that group of gases that kind of hold the Earth in check. So look at that. We probably will not have time to really look at the biosphere as far as life on Earth here in this course. Anyway, if we were running the 16-week course, it certainly is something that we would look at. But as I said, the geosphere is where we're going to spend a whole lot of our time looking at the solid Earth. And this is also the largest of any of those spheres that I just mentioned. So we'll look at solid Earth, and as well as the liquid Earth, the magma. One thing to remember is, magma is really lava that's inside the Earth. Once it exits the crust of the Earth, we just rename it as lava. So magma and lava are basically the same thing. So we'll look at things from outside in, so we'll begin, of course, with the crust of the Earth, Then move into the mantle, which of course is important because over 80% of the Earth's volume is located in that mantle. And we're going to break it into two pieces. The upper mantle, which is the lithosphere and the asthenosphere. But the lithosphere is especially important because that's the crust of the mantle. And then we'll look at the second part, which is the lower mantle, which is, the part that's really extremely hot. And this is the part of the Earth that really strengthens with depth. So as we move down from the surface of the Earth, the mantle is getting stronger and stronger. And then below that is the core, what we call the core of the Earth. And again, we'll break that into two pieces. The outer core, which is liquid layer of the Earth, and this is where you're going to find the magnetic field of the Earth. And then the inner core, which is solid Earth. So those are the two distinctions. Outer core is liquid, inner core is solid. As far as makeup, we're looking at the core being made of iron and nickel. It's basically an alloy of those two things. And then another piece that we will cover in depth, starting after the rock cycle, will be plate tectonics. We'll look at the slabs of the Earth and how those move along particular plates. Important thing here is to remember that the Earth is in continuous motion. So we'll take a good look at that and exactly where these plates are located. We know that while the plates are in continuous motion, they're moving very, very slowly. So we'll take a look at that, as well as the types of boundaries that we have on our plates, right? The divergent, plates that move apart from each other, convergent plates that move together, and then the transform fault plates that move side to side. They slide kind of back and forth between each other. So, and then the last piece, we'll look at the continents itself. What exactly are they made of? This is where the rock cycle is going to come into play. Mountain building, all of those things like that. Right, the formation of the continents, and then the movement of the continents along those plates. Those will be kind of the main things that we'll be covering as we kind of move through Earth science. And then we'll finish up by looking at, the Earth being a system unto itself, right? Systems are dynamic, they're always changing, and the Earth is no different. So we'll take a look at, the two types of systems, whether it's a closed system or an open system, and know that the Earth, of course, is a system itself because it consists of lots of different subsystems that we'll study, like the water cycle and the rock cycle and so on. And then, the last piece of this, of course, is that we are all part of that Earth system. So that'll kind of bring together our last 6 weeks of the course. I'm going to be putting that introductory assignments into Blackboard today. As all assignments are going to always be due Sunday of the previous week at noon. So this first assignment will be due next Sunday at noon. All right. If you have any questions, please email me. This is a totally synchronous course, which means that it's 100% online. And we will not meet together at the same time in the same place. So If you have questions, please drop me an email. In the introduction, the email is listed, but I'll say it right here. It's riasillo@roosevelt.edu. Drop me an email, and we'll get everything figured out. So that's it for week 1. Look for the assignment, and I'll be posting some other things week 2. Also, please, pay attention to the discussion board. So these are things that you should be checking regularly, right? The looking for the lecture PowerPoint, looking in assignments, and checking the discussion board. Need anything, drop me an email. Thanks.